Welcome! Ever wondered how large applications manage to keep working smoothly when the services they rely on change? That's precisely where API versioning becomes indispensable. Just like any evolving software, APIs frequently gain new features, improve performance, or even deprecate older functionalities. Without a well-thought-out versioning strategy, these updates could suddenly break every single application that depends on your API, leading to frustrating outages. Versioning allows you to introduce significant changes without forcing all your clients to upgrade immediately. It provides a stable, predictable path forward, letting consumers adopt new versions at their own pace. This practice is absolutely crucial for maintaining long-term API stability and building strong client trust. Ultimately, it means happier developers and more robust, resilient systems for everyone involved. Now let's dive into some common strategies, starting with one of the most straightforward, URI versioning. This method involves embedding the version number directly into the API's URL path, like /v1/users or /API/v2/products. It's incredibly simple to implement and very easy for developers to see which version they're interacting with just by looking at the URL. However, a potential drawback is what we call URL proliferation. You end up with many different URLs for essentially the same resource. It can also be less flexible for very minor, non-breaking changes, as even small updates might tempt you to bump the version in the URL. Next up is header versioning, a more nuanced approach. Instead of the URL, the API version is specified within HTTP request headers. Often this uses the accept header, where you might send something like accept application/vnd.myapi/v2 plus JSON. This method keeps your URLs cleaner and is often considered more compliant with REST principles, as the resource identifier remains constant regardless of its representation. The trade-off is that the version isn't immediately visible in the URL, making casual inspection a bit harder. It also requires clients to explicitly manage and send these custom headers with every request, which can add a slight layer of complexity. Another common technique is query parameter versioning. Here, the version number is appended to the URL as a query parameter. For example, /users query v = 2 or /products query API version = 3. This approach is quite easy to implement and test as you're just adding a simple parameter to your existing URLs. It also allows for quick switching between versions during development or debugging. However, a significant downside is that it can interfere with caching mechanisms, as each version essentially creates a unique URL for the same resource, potentially leading to less efficient caching. Also, from a purist's perspective, it's often considered less RESTful because the version isn't truly part of the resource identifier itself. So, with these strategies in mind, how do you choose and implement them effectively? First, version early and consistently. Don't wait until you have breaking changes. Establish a strategy from the start. Second, document all API versions thoroughly. Clear documentation is your client's best friend, detailing changes, deprecations, and upgrade paths. Third, when you do introduce new versions, deprecate old ones gracefully, providing ample warning and migration guides. Finally, always consider your client's needs and your API's future growth. The best strategy is one that balances ease of use for consumers with flexibility for your development team. By following these principles, you'll build robust, maintainable APIs that stand the test of time.